depends upon the quantities of matter or size of the system, that is called extensive property. Suppose volume, suppose you are in the room, whatever the volume, suppose it is the 100 square 100 meter cube. Suppose volume is 100 meter cube. Now you divide, suppose this is my room where I living, suppose this volume is 100 meter cube. Now we divide this room to imaginary boundary I kept, imaginary boundary. Now this room is divided in two parts and its volume is 50. So volume is an extensive property. Similar also volume is extensive property. Enthalpy, entropy, mass is also an extensive property, because mass means, suppose you choose 10 potato, whatever is the mass, suppose I tell that the mass 10 potato, suppose the mass is 1 kg. Now this 10 potato you divide into 5 potato in each part. So 5 potato means now it is 400 gram, now it is 600 gram, because potato is not same size. So 400 gram. So when the same 10 potato we divide into 4 parts, the mass will decrease. So mass is an extensive property because it depends upon the quantities of matter. Similarly, mass, volume, enthalpy, entropy, all are internal energy, heat capacity, free energy. These are all the extensive property. Similarly, also we call the state function and state variables. State function means the fundamental property which define the state of a system is called as the state function. That means, suppose we consider a beaker, we have considered 5 pieces of ice. Suppose we tell that the temperature, whatever the ice is present, it is 0 degree centigrade. We know that the ice is in the solid state. Suppose we tell that after some time, after 10 minutes or 15 minutes, when you again reach here, the all ice is melt and converted into liquid state. Suppose one will tell me that the temperature of the system is now 10 degree centigrade. I think that ice is not in the solid state, that was converted into liquid state. So temperature, similar also temperature, same thing happen, pressure, same thing happen, volume and composition. These are called as the fundamental properties. So the property which define the state of the system, then it is called as the fundamental properties. So state functions, but state variables. So these are but pressure, volume, temperature and pressure, volume, temperature and composition. These 4 are called as the fundamental properties. But enthalpy, internal energy, free energy, work function, entropy, these are also called as the thermodynamic property. Both are fundamental property and thermodynamic property are called as the state function, but state variable. Remember, if you do not know whatever is state function or state variable, only you remember that heat and work, these two are the path function, because it depends upon the path followed. Living heat and work, whatever the property you can want to know, these are all are the state function or state variables, but heat and work are the path function, but all others are the state function. Suppose one tells that there is small change in temperature, small change in composition, small change in enthalpy, internal energy. When there is a small change in fundamental property occur, we can write du, one small change in internal energy, dH, small change in enthalpy, dG, small change in free energy, dt, small change in temperature, similar as dP, small change in pressure. When we small changes are occur in the state function or state variable. We define them, but we designated, but we denoted them as du, dh, dg, dt, dp, d. These are called derivative. But when we tell that the small change in occur in heat and work, suppose heat and work, suppose I tell that heat we measure in Q, work we measure in W. Suppose we tell that the small change in heat occur, we cannot write du, we can write del Q and we can write del W. And del W means del W del Q. Del W means small change in work. Del Q means small change in heat. So when you denoted the state function and path function, the state function is denote small change in state function by state variable denoted as d, while small change in path function is denoted as del. This is the when there is a symbol like del means you know that these are the path function. When there is a small like d means you know that these are the state functions. Sometimes the path functions may be a state function, but in that case we write d. So from the symbol you can know that d means small change occurs in state function, del means small change occurs in path functions. There is a certain path in which work and heat can be act as a state function. We will tell you later when come heat and work, when we determine, we will tell you at that time. When the state heat and work as considered as a state function, and when it is considered as a path function. Similarly, we can define the process means the thermodynamic process. The thermodynamic process is the process in which the thermodynamic system moves from one state to another state. Suppose thermodynamic system means, suppose it is a beaker, it is three or three pieces of ice. After some time, we see that this ice is melt and liquid water. So here ice is converted into water. That means it is a thermodynamic process. So that means the solid state ice is converted into liquid water. So how the ice is converted into water? Now it absorbs heat from the surrounding. When it absorbs heat from the surrounding, the temperature of the ice increases, it is converted into water. But it is a thermodynamic process. Conversion of ice into water is a thermodynamic process. Similarly, when you take a beaker and you take water and suppose you write some food grains, so when you heat this beaker, this is converted into that. We see that the food grain is completely mixed. Or suppose you take the dal in water, this completely dal is formed. It is a thermodynamic process. So this is the thermodynamic process is the process in which the state of the thermodynamic system changes from one state to the another state. It's called as the thermodynamic process. There are the different thermodynamic process. One is isothermal thermodynamic process. In isothermal process means the process which takes place at constant temperature. That means dt is equal to 0. That means there is no change in temperature. That means ice is converted into water, but temperature will remain same. That means temperature will not change. Similarly, that means dal is converted into the mixed form, but temperature will remain same. Temperature system will not change. That means isothermal process. How it will occur? Suppose this is my ice is converted into water. You know that ice is absorbs heat from the surrounding and temperature of the ice increases, it is converted into liquid water. But we tell that it is a thermodynamic process, it is a isothermal process. If the ice is converted into water, then I tell that it is a thermodynamic process. If I tell that ice is converted into water in isothermal process, that means whatever the temperature is here, the temperature is also is here. But how it is possible? That means we can change the pressure, but with temperature will remain change. The temperature will remain constant, but pressure will change. When you apply the pressure, when you implicate the pressure in the ice, it is converted into the water. So that means any process in which the temperature will remain constant, it is called as the isothermal process. Similarly, in isobaric process means the pressure will remain constant. Isobaric process means the pressure will be remain constant. dp is equal to 0. That means that here ice is converted into water, but it is 1 atmosphere, it is 1 atmosphere. Pressure will not change, but temperature can change. That means it absorbs temperature in the ice. It is open container, suppose it absorbs heat from the surrounding, converted liquid water. Whatever the pressure here also pressure it remains same, but temperature, but in case of isothermal, temperature will remain constant. You think that when you increase the pressure, temperature automatically increase, no doubt. But how you fix the temperature constant? That means you put a reservoir. Reservoir means which then it is a sink. That means sink is a reservoir. That means when you increase the pressure on the, suppose there is a piston, when you push the piston downward, piston will come downward, the pressure will increase and temperature automatically increase. But we keep the temperature constant. That means we put a sink here. Whatever the temperature increase, the temperature will return to the sink. So sink temperature will increase, but the system's temperature will remain constant, but is converted into the iso. That means in isothermal process, temperature remain constant. In isobaric process, pressure remain constant. Similarly, in isochoric process, volume will remain constant, volume will not change. Volume is the initial state, whatever is there. Final state also volume will remain same in isochoric process. So that means in this cases the piston will be fixed. That means here ice converted into water, but it temperature can increase, pressure whatever change will pressure can increase, but volume will remain constant. That means this piston is fixed. In this piston will be fixed. That means in case of isothermal process, this piston should be frictionless, weightless. But in case of pressure, in case of constant pressure will be remain same, and in constant volume will remain same. That means this piston is fixed with the container. Similarly, in adiabatic process means, adiabatic process is the process without exchanging heat between the system and the surrounding. That means, suppose without exchanging heat means that suppose it is a beaker you put, suppose here you put sulfuric acid, then you take zinc inside it, and we tell that without exchange of heat between the system and surrounding. System ru surrounding को heat जीवनी के surrounding ru system को heat जीवनी के system ru surrounding को heat जीवनी. That means del Q is equal to 0, but dq is equal to 0. There is no exchange of heat between the system and the surrounding. That is called the adiabatic process. So this is always, but temperature can change. Temperature ଭିତରେ ବଢିଯିବ. So it is exothermic. This reaction is exothermic. Temperature increase, but this increase in temperature will not move outward. Surrounding को exchange करिबनी के surrounding ରୁ कौनसी heat बाहर को system भीतर को जीवनी. This is called adiabatic process. So then it is a cyclic process. Cyclic process is the process in which the system undergo number of different process, but finally returns to the initial state. That means this is the initial state. It moves here downward, moves again left, then moves again upward. Wherever is there, it comes here. That means it is called cyclic process. In cyclic process, what happens? Wherever the initial state is there, final state also is reached here. That in cyclic process, change in internal energy is 0. Change in enthalpy also 0 in cyclic process. That means you go to तुम घर को जाइछ, घर पुणी कॉलेज को आसीबो, घरे जेमति पढुथिल, घर को आचरण इनिशियल से cyclic process तुमर हे गला. So इस cyclic process रे कोन होची, चेंज इन इंटरनल एनर्जी 0 हो जिवो, चेंज इन एंथैल्पी मध्य 0 हो जिवो. बेंग पसी आसिला, हे बेंग ऐसा हबियो भागति तो. Cyclic process is the process in which there is whatever the initial state, it returns to the final state. that is called cyclic process रे internal energy change in internal energy zero, change in enthalpy ମଧ୍ୟ zero। ତା ମାନେ ଯଦି ବୁଝିବାକୁ ହବ ତୁମେ ହଷ୍ଟେଲରୁ ଘରକୁ ଗଲ, ଘରେ ବୁଲାବୁଲି କଲ, ସବୁଆଡ଼େ ବୁଲାବୁଲି କଲ, ପୁଣି ହଷ୍ଟେଲରେ ଆସି ପହଞ୍ଚିଯିବ। ହଷ୍ଟେଲରେ ତୁମେ ଯେତେବେଳେ ପହଞ୍ଚିଥିଲ ସେତେବେଳେ ତୁମର ମାନେ ଯାହା ଏନର୍ଜି ଥିଲା ଘରେ ବୁଲାବୁଲି କରି ହଷ୍ଟେଲକୁ ପହଞ୍ଚିଗଲେ ମଧ୍ୟ ସେତିକି ଏନର୍ଜି ଆସିବ ବୋଲି ଆମେ ସାଇକ୍ଲିକ୍ ପ୍ରୋସେସରେ କହୁଛି। ଡି ୟୁଜ୍ କଲ, ତେଣୁ ତୁମେ ଘରକୁ ଯାଇଛ, ପଢ଼ାପଢ଼ି କରିବ, ପୁଣି ଆସି ହଷ୍ଟେଲରେ ପହଞ୍ଚିଗଲେ ସେତିକି ପାଠପଢ଼ା ତୁମ ପାଖରେ ଥିବ, ପାଠପଢ଼ା ଲସ୍ ହେବନି ବୋଲି ସାଇକ୍ଲିକ୍ ପ୍ରୋସେସରେ କହୁଛି। But it is not possible. We are not reversible. These are the reversible cases. We are all are reversible only ideal process. Reversible process is not possible. It is just ideal process. Then we come to the reversible process. Reversible process is the process which takes place infinitesimal slowly after attaining the equilibrium. That means after attaining the equilibrium means, suppose this is my one system, this is my another system, and we tell that this system are in equilibrium. That means once this system 1 is equilibrium with system 2, once attain the equilibrium higala mane the infinite number of steps are required to complete the reaction. So infinite time is required. That means system 1 converted to system 2, then system 2 converted to system 1. This is reversible process. After attaining the equilibrium in the reversible process, after attaining the equilibrium, then infinite number of steps are required to complete the reaction. As infinite number of steps are required, so infinite time is required. So in order to make the reversible process or reversible process to complete, then it is infinite time is required, but it is not possible. So example is frictionless adiabatic expansion or compression, frictionless isothermal expansion and compression. Then irreversible process. Irreversible process is the process which takes place rapidly without attaining the equilibrium. So it takes place a few number of steps, 3-4 steps or 1 steps or 2 steps. So finite time is required. All natural processes are irreversible. All combustion processes irreversible. Heat flow from high temperature to low temperature is irreversible. केबे लो टेम्परेचर हाई टेम्परेचर हीट फ्लो हेनी, ताने आइसटा वन्स लिक्विड वाटर कन्वर्ट होती, पुणी लिक्विड वाटरटा आइस को कन्वर्ट होनी सराउंडिंग एटमोस्फियर रे। तेणु all heat flow from always heat flow हम हाई टेम्परेचर रू लो टेम्परेचर, हाई टेम्परेचर रू लो टेम्परेचर को हीट सदा फ्लो हम, लो टेम्परेचर हाई टेम्परेचर को हीटा फ्लो हेनी। So all combustion processes are irreversible process. All natural process, all processes involving friction सब जाक होची irreversible। आमे चालुचे गाड़ी जाउची पृथ्वी बुलुची जहाँ भी करची सब जाक फ्रिक्शन अछि, विदाउट फ्रिक्शन वर्क किछि कन्वर्ट हेबनी। सो ऑल आर irreversible process। हमर एनर्जी खर्च हबो, आमे ताने ई साइक्लिक प्रोसेस मु जो कहली जे तुमे से दिक पाठ पढिथिल घरे बुलाबुली करि आसी पुणी हॉस्टल पहुंची सब जाक पाठ जहाँ थिबो ता नॉट पॉसिबल बिकॉज it all are irreversible process. This is possible only in case of reversible, but it is not. But reversible process is preferred because working fluid delivers more work than that of the irreversible process. We will tell you when you derive the expense work done by reversible and irreversible process. The reversible process occurs in infinite number of steps, so infinite time is required. So for its completion in case of reversible process. So today we stop here. This is whatever we taught you in the thermodynamics class. We just recall you. So in the next class we will go forward from the 0th law of thermodynamics. So खुदा हाफिज। ओ भगवान भलरे थाओ, घरे रही थाओ। बाघ बुलुची, बाहर को आसला माने बाघ तुमको खाइब, बाहर को आसबनी, घरे थाओ, पढ़ापढ़ी कर।